Welcome to the PLASMA.show tutorial. PLASMA.show is a web-based WebGL app that can be used to demonstrate various aspects of magnetic containment for plasma fields. When you open up the app and click full screen button, you're greeted with the coordinate system of the toroid. If we click and drag, we can rotate the camera to look around the toroid, and we can zoom in and out with the mouse wheel. Okay. Below each topic toggle button, we have a set of sliders that correspond with it, and these sliders adjust parameters on the 3D meshes to affect them in real time. So we can adjust the cutaway slice to change how much of the toroid is cut through. We can change the toroidal angle to get a real feel for which axis we're referring to. And the Poloidal angle, you can rotate that around, get a good feel for that. Below that we have major toroidal radius adjust. Pull it in, adjust it to where we want, and the same with the minor poloidal radius. We can adjust that radius too. When we're finished with a topic, we can click the toggle button and that sweeps it away. We can click the next toggle button and open flux surfaces. These are some nested D-shaped flux surfaces. You can rotate, have a look around. And we have various sliders under here. The cutaway slice, we can bring that all the way around to make a complete loop. And we can pan out and look top-down view on it. We can adjust various disruptions like the Kink Disruption, change the amount, and we can also change the M mode in real time to see how the increasing M mode number changes the repetitions around the toroidal axis. And we can have a good look around to see how each slider affects it. Let's take the kink down and show the sausage disruption coming in and out. And again, we can zoom around and take a good look. We can pull the cutaway slice out a little, and we can sweep it across the cross section and get a really good feel for how the cross section changes as we cut through the toroid. Okay, let's take the sausage to 0 and increase ballooning, and we can see ballooning ripples the edges of the toroid, and the ripples are greater on the outside because the magnetic field is stronger on the inside of the toroid. And again, we can adjust the M mode to increase the symmetry, the repetition symmetry around the poloidal cross section. Let's take ballooning off. We can also add some shear lines, and these shear lines can be used with the magnetic shear slider to show how magnetic field lines on the inner flux surfaces orbit more often than the lines on the outside flux surfaces, so they twist tighter on the inside surfaces, and we can bring them right round, looping on themselves, and take a 3D look at how the inner magnetic field lines spiral more tightly than the outer ones. Okay, we can even combine that with the disruptions, and the field lines ripple and distort along with the flux surfaces. And also distort with the kink and the sausage disruptions. Okay, let's take the shear lines away and add some passing particles. And if we get the angle right, these are spiraling around one of the inner flux surfaces, and we can see they spiral around the poloidal cross section, and if we zoom up we can also show that they orbit in the toroidal direction as well. If we wanted to see the ion gyration, we can click the G button, and that turns on the slow motion ion spiral effect to get a feel for how the ions spiral around their own paths. Take a look around, get the feel for the different views. And we can turn gyration off, which is known as ALF mode. Okay, let's get rid of the particles. We have a slider called the Shafranov Shift, and we can use this to demonstrate that as the temperature and plasma pressure increases, the flux surfaces, the magnetic flux surfaces, are pushed towards the outside of the donut. That's the Shafranov slider. Okay, if we click the famous banana orbit, we can see that there's a crescent-shaped cross-section with a marker showing the current cross-sectional position of the particle as it does its strange trapped orbit, bouncing around. We can take away flux surfaces and take a good look, and we can see there's a crescent-shaped cross-section here, and the markers moving around the outside. And if we look top-down view, we can see the particles bouncing around, trapped on this strange banana-shaped cross-section. If we rotate right round, we can get a really good intuitive feel that the particle is travelling down on the inside of the banana cross-section and up on the outside of the banana cross-section. And by looking around in 3D, we can get a good feel for that quite complex three-dimensional path of the trapped particle. Okay, let's take that away. The last topic toggle button is for the plasma, and this is a crude example of a plasma toroid with a gentle glow effect on there. And we can explain that the actual body of the, it looks like this because the actual body of the plasma is so hot that it's emitting in the X-ray spectrum, and it's only the very, very edge, the cool edge of the plasma, that actually emits in the visible spectrum, which is why we get that strange pink edge glow to it. There's also a field line here with a couple of sliders. We have poloidal pitch, which we can adjust, get a feel for how the poloidal pitch changes as that field line rotates around the toroidal axis. We can take that poloidal pitch all the way around to do a single loop per toroidal lap, and we can also increase the toroidal laps to show how a single field line, if we get the right pitch and the right number of orbital lapse, we can see the field line starts to flow across and up the inside of the surface and down the outside. And if we get the pitch and toroidal lapse exactly right, that single field line can describe the entire toroid surface in 3 dimensions. And we can take a good look around there, and we can fold that back up. The last button here in the end is a little background color change. Let's say we had coordinates open and we wanted to do a screen grab and print it out. To save wasting all your black ink, we can change the background color to white. You can get the angle you want and then do a screen grab and print it out. Or we can have flux surfaces with some shear lines, take them all the way around, and we can grab that and print with a white background. We can grab with the black background for web images, that sort of thing. Okay, that pretty much shows all the features of PLASMA.show WebGL app. Thanks for listening. I hope you enjoyed the tutorial.